Hi everybody, in this video we are still in our unit on linear equations and we are looking at example 2. We are solving another linear equation, this time with fractions, and we're going to just go over technique, strategy, all very important things of what you should do to think smarter, not harder, and make your life a lot easier. Now, in chapter R, the review chapter, I did go over dealing with compound fractions or complex fractions and how to clear out all these extra fractions. In the case of dealing with an expression which does not have an equal sign, we multiplied our numerator and denominator by the same number, which is allowed because that same number, anything over itself, is uno, right? That's 1. So if I multiply by 1, that's okay because you can multiply by 1. 1 is multiplicative identity, right? So I can do that. In this case, that's not going to be as helpful. In this case, what I want to do something sort of equivalent, but more tailored toward an equation. So what I'm going to do instead is I'm going to multiply both sides of the equation, but I kind of represent that by just drawing a giant parenthesis, okay? Sue me. I'm going to multiply both sides of the equation by that same type of number. What is that number? The least common denominator that I would use if I were to be trying to combine all of this stuff together. So what is the least common denominator in this case? The least common denominator between 3, 2, 4, and 3, it is not 24, and it is not, anything bigger than that. You have to remember that 2 is already a factor of 4, so it's sort of redundant to incorporate 2 if you already incorporated 4, right? So the LCD, lowest common denominator, is 12. Now, another thing you need to remember when doing this strategy is that when you are multiplying by this 12 and doing famous PEMDAS, right? When you are doing that, you need, sorry, I'm just looking for a different color to get one of these steps going nicely for us. You need to remember that PEMDAS is sort of a lie and that you are allowed, in this case, I would even say encouraged to divide before you multiply. Divide before you multiply, okay? So why do we do that? Because it makes numbers smaller. That's similar to how at times I'm going to subtract before I add, right? I want to be as efficient as possible when I'm doing problems like this, okay? I want the numbers to be smaller. I don't want to have to pick up a calculator and just want to get things done, okay? So let's watch what I mean by that. So if I distribute the 12, I'm going to reduce the 12 with the 3 to start. 12 divided by 3, I'm going to uncross it out because I don't want to have that mess there, is 4. And then I'm going to take 4, okay, and multiply that by the numerator, distribute that there. So 4 times 2x plus 4 is 8x plus 16. Boom. Next, 12 times this. First thing I'm going to do, reduce 12 and 2, and that's 6. Then what is 6 times 1 times x? Well, that is 6x. Lovely. Next, we have 12 times 1/4 x. So I'm going to reduce 12 and 4. That's 3. 3 times 1 times x is 3x. And last, 12 times 7/3. I'm going to reduce 12 with 3. That's 4. And 4 times 7 is 28. Now, these are both equivalent equations, I promise, okay? Both of these are equivalent equations. We just basically took one equation and scaled it up or down. That's all that's happening from one to the other. And they look different, but they represent the exact same data, exact same information, exact same relationship. So now we can go ahead and solve good old classic solving algebra. So I'm going to combine like terms. 8x plus 6x is 14x. Little mental math tricks. I would think of taking one of the numbers away from the 8 and giving it to the 6. So it's 7 and 7 because I know 7 and 7 is 14, right? Great. Then simultaneously, I'm going to subtract 16 from that side, minus 16. It'll be there on the other side. There's my equal sign. That's what constitutes one side or another. And I'm going to subtract 3x from this side. So it's gone from there. Sorry, my work is a bit of a mess this time. So 14 minus 3x, well, that gives me 11x on the left. Negative 28 minus 16, that is negative 44 on this side. From here, to get the x alone, we're going to divide both sides by 11. And that leaves us our final answer, x equals negative 4. So that makes this solvable. We got one solution. That makes this a conditional equation. It's true that the left side equals the right side under a condition when x equals negative 4. All right, so always try to clear out your fractions. It makes problems way more friendly, way more approachable. If you get it, you got it, and you good, then go ahead, put a thumbs up. If not, put a thumbs down so that you know you've already been here, done that. Questions, comments, concerns, feedback, let me know, and I'll do my best to help you out. Check the playlist to find more of what you're looking for. Bye.